Good morning, friends. My name is Ashutosh Garg. I work as a solution provider with Furnace Improvements. Our company is in the business of revamping fire heaters and supplying new fire heaters. We can take your fire heater and bring it to the highest efficiency, longest run length, and highest capacity. This webinar today is born out of our experience and dealing with customers like you for more than 40 years. This is our 5th webinar and I welcome you all. I hope all of you are keeping safe and taking all necessary precautions during this COVID pandemic. So today we will be talking about a very important topic. This topic not only concerns us, but it also concerns every human being on this earth. That is how important this topic has become. And this topic about reducing your carbon footprint and saving your money is almost like, some people think that it is almost like existential threat to the mankind, the global warming. So I thought we will talk about this important topic and see how we can do our part, reduce the footprint in our refineries, carbon footprint in our refineries, and at the same time save money so that these projects can pay back. So that's what we will be talking about today. And especially if all of you know that fired heaters are major source of carbon dioxide emissions in refineries. It's been categorized as a pollutant and accounts for 2/3 of all the greenhouse gases. So many countries are now imposing tax on emissions of carbon dioxide. And I think all of us need to do our part by reducing our carbon footprint. One way is to improve the fired heater efficiency, and that's what we will be focusing in this webinar. So join me and I will be presenting some basics, some case studies, and anytime we have done this webinar, we have learned something from our participants. So feel free to send me questions. We will be conducting this webinar today through PowerPoint, and we will have a presentation for about 50 minutes and then a question and answer session for about 10 minutes. Give us your suggestions and give us your feedback so that we can improve our next webinar. I'll start the session with a brief introduction of myself. I'm a chemical engineer. I passed out from IIT Kanpur in 1974. And since 1976, I've been working on fired heaters and combustion systems. I have worked in KT India, Engineers India, and KTI Corporation in the US. Since March 1996, I've been working at Furnace Improvements and improving fired heaters for the past 25 years. So I want to start by thanking our team in the US and in New Delhi for developing this presentation and webinar and even marketing it. So our team of process mechanical engineers, they deserve a big thank you for putting this presentation together. I am the front end or the presenter. That's my role today. Before we talk about our webinar, I need to tell you a little bit about our company. Furnace Improvement started in March of 1996. We'll be completing 25 years next month in business. We currently have 3 offices. Our head office is in Sugar Land, Texas. We have an engineering office in Noida, India. We started it in 2005. We have about 35 people in that office, and these this team is doing everything. They are doing process, mechanical, structural design, drawings, as well as drafting. We also have a 3D modeling capability. We are a full service heater company and we execute projects on turnkey basis, including erection. We have a CFD office in Pune, India. We started it in 2014. Our CFD team has been working exclusively on combustion, heat transfer, and fluid flow problems. We have been working on improving the performance and efficiency of existing fired heaters for 25 years now. And we have carried out these revamps in a very, very systematic way. We have also challenged the conventional approaches being followed in the design of fired heaters. We have some new technologies that can help in reducing carbon footprint and can also help in improving the efficiency of fired heaters at a much lower cost than the conventional revamp. So I will present one case study for you. That will be what we want to show to you today. So our agenda today will be talking about the carbon footprint and a little bit about combustion process and how we can reduce our footprint, how we can minimize the carbon dioxide emissions. I have some case studies for you, and after that, we will be talking about question and answers. We will be having question and answer session. Before we start, I want to thank our clients who have kept us going for the past 25 years. They have put their trust in us, and companies like Phillips 66, Countrymark, Delex, Citco have been our long-term clients, and they have been supporting us. So thanks to all our clients for putting their trust in furnace improvements. So carbon footprint is very simple. It's the greenhouse gases, like gases which are like carbon dioxide, methane, and some other gases have been termed as greenhouse gases, and they are trapping heat. What they do is they trap sun's heat, and it leads to the global warming. So that is why these gases have become important. I think you would have heard in the past 30 or no 40 years now or 50 years now, we had been focusing on NOx emissions because that was kind of leading to smog, and it was almost like a war which was fought everywhere to reduce the NOx emissions to clear the smog. So now we find that it is the carbon dioxide which we had been emitting maybe for 100 years. The refining industry is about 110 years, 120 years old, and we have been working or we have been combusting initially liquid fuels and now gaseous fuels, and they are all hydrocarbons. They lead to production of carbon dioxide, and that is what is kind of contributing to global warming. So let us see how we can reduce the emission of these gases from our fired heaters. So I think all of you are familiar with fired heaters. It's a very unique equipment. It's used for high temperature heat transfer equipment. And it's used places where heat exchangers are not economical. I mean, for high temperature heat transfer, what we find is fired heaters is the only economical way of achieving that heat transfer. And one keyword which differentiates this equipment with the rest of the equipment is fire. We have combustion taking place inside the furnaces, and that distinguishes it from the rest of the equipment. We don't have that. So let us see how we can understand to improve our uh, furnaces, improve the efficiency. So in fired heaters, the fuels, hydrocarbon fuels are burnt, and the chemical energy in those fuels is converted into thermal energy or high temperature flue gases. And those high temperature flue gases radiate heat. So 60 to 80% of the heat to the fluids is transferred by radiation, and anywhere between 20 to 40% of the heat is transferred by convection. So radiation and convection are the two major heat transfer means by through which the heat is transferred to our fluids like crude oil or vacuum feed or hydrocracker feed, and then they are kind of heated to and distilled. There are many types of fired heaters. We are not going to go into details of fired heaters. Single fired, double fired, top supported, bottom supported, vertical and horizontal radiant tube. There are different configurations, and they have been changing for last 100 years. So it is not that we have one designs, but the basic principle has remained the same. One thing which we want to talk about is our business, and we are in the refining business, and it's a very matured business. It is not like software or internet or social media. It is a business which has seen its heydays in 1950s, 1960s, and now it is kind of, should not say it, it is kind of in the declining mode. If you see the chart which I have presented in 1980, we had almost 250 refineries. In fact, if you go back to 1960s, we had 330 refineries in this country, in US. And today, the number of refineries is down to 135. So almost 200 refineries have closed down in the past 50 years. So we are in the survival mode, and we don't know how long we will continue, but it appears to me that only the fittest refineries or which refineries which have the lowest emissions will be able to survive, because sooner or later there is going to be some sort of carbon tax or carbon credit, whichever way you want to term it, imposed on these industries. And if you're not efficient, if you're not taken yourself steps to meet the latest challenge, you will be out of your business. So what I did was I looked at the state of fired heaters in US, and one thing I want to tell you is that even though the number of refineries have gone down, our refining capacity has more or less stayed the same. So the refineries which are open have been continuously improving and increasing their capacity so that they can meet the country's need of refined products. So our refining capacity has more or less stayed the same. And in the refining industry, I believe we have got 3,000 furnaces in the US. My data is all from US. And 90% of these heaters are natural draft heaters. And I think only about 3 to 5% of the heaters in this country have air preheating systems. A natural draft heater's average size is about 72 million BTUs, and forced draft heater is 110 million BTUs. And that's this kind of picture is what drove me to conduct this webinar today, because when I see 90% heaters are natural draft heaters, to me it appears that there is a big potential for efficiency improvement. We have seen heaters or refining heaters in other parts of the world, and what we find is the heaters in India, in Korea, in other Southeast Asia are a lot more efficient than the heaters in the US. There could be several reasons. The energy cost there is very high. That could be one reason. Other reason could be that these heaters are much newer, whereas in the US, the refining industry is pretty old. So that could be another reason. But today, when we look at this, it presents us an opportunity to reduce carbon dioxide emissions and also reduce uh, the fuel cost by improving efficiency. So I want to talk to you a little bit about the petrochemical industry in US. Petrochemical industry basically comprises of petrochemical plants for producing ethylene. All these have high temperature cracking heaters. And then we also have industries like hydrogen, ammonia, methanol, which have steam hydrocarbon reformers. And these, we have almost like 1,600 heaters, maybe even more actually, maybe 2,000 today. Average size is much larger. Now, one thing which we have observed is the fired heaters in the chemical industry are a lot more efficient than their counterparts in the refining industry. We have seen if you look at cracking heaters, they are targeting 94, 95, 96% efficiency. Now, if you see the refining plants and the petrochemical plants are side by side, and on one side we have heaters which are 70% efficient, and over the fence, the next plant, we have heaters which are 95% efficient. And it's very hard to understand why is there a difference of approach. And to me, it appears that it could be the fuel cost. In refineries, the fuel gases are practically free, and it's only the bought out gases which cost money, whereas in the petrochemical plants, all the fuel is bought out. So that kind of makes the change, changes the situation. And once you are buying fuel, you are paying for it, and then you become a lot more vigilant and you become a lot more efficient. So same company, petrochemical 94% efficient, refining 75% efficient, and it gives us a big potential efficiency improvement potential there. So I kind of calculated. I did a quick calculation with 90% natural draft heaters in the refining industry. I estimated about 75% efficiency, current efficiency, and we can easily raise to 90%. I think we can even go to 95 actually, but let us take a conservative approach to 90% efficiency. And to me, it gives a very quick number of almost $1.5 billion a year. That is how much energy saving potential is there. At the same time, when I look at the carbon dioxide emissions reduction potential, it's a whopping $430 million 430 million tons per year, or almost $1.7 billion. I'm using a carbon tax or carbon credit of $40 per million ton of CO2. I did some research on Google, and the number can keep on changing, and they think it can go all the way up to $150 to $2,000, depending on the time and supply and demand. So when you look at it, if you look at the fuel savings, it is 1.5, but if you take the CO2 tax credit, it doubles your savings. So the payback potential becomes a lot faster, actually. And that's what I think we should be able to talk about. Now, how to reduce your carbon footprint? I have listed 3 approaches over here. One is changing fuel to fired heaters. Other is reducing flue gas temperature. The third is reducing excess oxygen in flue gas. So 3 approaches, all simple approaches, is what we can talk about here and do our part and reduce our carbon footprint. So the first research I did is what would happen if you switch to hydrogen-rich fuel gas. And the reason I'm talking to you is one refinery in Europe contacted us and asked what would happen to fired heaters, how would its performance change if we switch to hydrogen fuel. So I did quick calculations for 3 fuels: natural gas, which is a common fuel in US and maybe in other parts of the world. Then I took a hydrogen-rich gas and approximately 90% hydrogen, 10%, 88, yeah, approximately that number. And the third is fuel oil, number 6. I don't think anybody is firing fuel oil, but most of the people are firing fuel gases. And I did a comparison. And what I found was if we switch from natural gas to hydrogen-rich gas, we can cut down our CO2 emissions by almost 50%. Now, if you switch to pure hydrogen gas, you are cutting it down to almost 100%. But the question is, from where are you getting this hydrogen gas? There are 2 established technologies as of today. The first one is by steam methane reforming. But there, we are using hydrocarbon fuels for combustion and even for reaction. So even though we generate hydrogen, we are still emitting a lot of CO2 in production of hydrogen. So in true sense, if we use hydrogen from SMR technology, we are not reducing our carbon footprint. We are only dividing it into 2, post and pre, But if we use hydrogen by electrolysis of water using electricity, then we can, in real terms, we can reduce our carbon dioxide footprint. But I think we are still 50 years away from that technology because generating electricity is very expensive, and unless we generate electricity using wind, solar, or nuclear, we will still be emitting carbon dioxide by burning of fossil fuels in power plants. So even though hydrogen-rich gases in your fired heaters is a good solution, uh, I think it is about 40, 50 years away if we are able to survive that time in refineries, but that's what I think actually. So my focus will be how can we minimize the heat losses in the fired heaters and maximize the efficiency and thereby the reduction. So a thumb rule is every 35-degree reduction in stack temperature increases the heater efficiency by 1%. And if you reduce your excess air by 15%, it gives you another 1% efficiency improvement. So today we can start targeting 250 to 300 degrees Fahrenheit stack temperature. We can target easily that temperatures, and we can increase the efficiency of our fired heaters to almost 94%. And this is typical trend we see from starting from 1960, around 75%, and then we had the two oil crises which helped us improve the efficiency of fired heaters, and today we are looking at 94%. So why 94%? Why can't we go to 100%? And we have two major limitations. One is the inlet fluid temperature. The flue gas temperature needs to be approximately 30 degrees higher than the inlet fluid temperature, and then the acid dew point. The tube metal temperature should be 20 degrees higher than the acid dew point to avoid condensation. So these are the two limitations on our efficiency. We can work on acid dew point because these days our fuel gases have very little sulfur, or some have practically no H2S. So that can gives us an added incentive to go down on the lower side of the flue gas temperature. I'm showing a curve over here. It basically talks about percentage H2S in fuel gas with respect to the dew point. And we are almost at very, very low. I mean, this is 0.01, we are even lower. Now, I do want to tell you that if you reduce excess O2, the dew point keeps on coming down. So if you go down to 0% excess O2, which may be possible, we can take care of the dew point. There won't be any sulfur trioxide formation, and we can cool down the gases almost down to about 150 degrees F. So the technologies are available, and hopefully my thinking is that we will keep on developing the new technologies to go down to almost 100, 150 degree F. But today we are talking of two typical technologies which we have used in fired heaters. One is waste heat recovery, generating steam. And this has been a very common method for generating steam in cracking furnaces, steam hydrocarbon reformers. If you need steam in your plants, this is a very good way of recovering heat from hot flue gases. I mean, you can recover heat to preheat boiler feed water, you can recover heat to superheat the steam, and then you can generate steam. So up to 93% or even sometimes even up to 95% efficiency can be achieved. The